checking out the video from last night. Of course, I'm so critical. I see some spelling mistakes, which are just careless, but I was editing it late at night and it was getting close to bedtime, and you know, things happen. But today we're going to be taking a look at how you wire up a regular receptacle in the wall. But remember, I'm not an electrical, I'm not an electrician, I'm not certified, but I'm going to try to show you guys how to do it anyway. The car is acting weird at low RPMs. It's like surging. Anyway, add it to the list of things that are going to break on this car probably. We are headed to the best place on earth, Wally World, Walmart, to pick up some vital groceries for tonight. And then we'll be working on the how-to video, how to wire a standard home receptacle in 4K, nevertheless. But first we gotta hit Wally World. And, you know, if you're going to Wally World, you're going to Walmart Liquors, which is right on the end there. So you get your food, then you get your drink on, right at the corner there. Yeah, this is Walmart, where sometimes you can't even find a freaking parking place. It's so busy. But I park right here in front of the grocery area. Building all these new apartments around it. Wouldn't you like to live right next door to Walmart? That'd be amazing. All right, we're gonna park and go up in this guy and see what we got. All right, guys, welcome back to the channel. Had a successful trip to Walmart and want to talk a little bit about what it's going to take to wire up a receptacle. Now, this is just a standard receptacle that you can buy at either Home Depot or Lowe's. It's a duplex receptacle. That's what it looks like right out of the box there. It's your standard Decorator. This says Decorator. So it's either Decorator or Decorator. Now the difference being, Decorator is the square type of plug, and the standard plugs are the round kind. So these tend to be a little bit more, I guess you would say, decorative, like it says on here. Now these are generally about, I don't know, $1-ish. They're cheaper if you want ivory, but nobody wants, I mean, if you want off-white, I guess that's called ivory. But the white ones are a little bit more expensive, not by much. So here's what you get in the package. So let's open this guy up and take a look at it. This is a cheap receptacle from either bought at Walmart or on Amazon. But I will link in the description to where you can get this guy. Before we take a look at how these guys work, you're going to have to know a little bit about how AC current works.
All right, so let's talk a little bit about what the difference is between AC current and DC current. And most of you who took electricity in high school, you are already familiar with what's known as DC current, which is basically electricity flowing in a constant direction and possessing a voltage with constant polarity. So the plus is always plus, the minus is always minus. Now, DC is the kind of electricity made by a battery, so that has a definitive positive and a negative terminal there, or it's the kind that's generated by certain materials rubbing against each other. Now, let's talk about AC versus DC. So, as useful and easy to understand as DC is, it's not the only kind of electricity in use. There are certain types of electricity, most notably rotary electromechanical generators, produce voltages alternating in polarity, reversing positive and negative over time. Now, either as a voltage switching polarity or as a current switching direction back and forth, this kind of voltage is known as alternating current. Okay, so let's talk about the difference. So an AC alternator is constructed to rotate a magnetic field around a stationary set of coils, and that's how that works. And the magnet is basically the voltage across the wire sees the magnet as opposite poles as it passes by them. So that's the difference between AC and DC. And then when you have your AC wiring versus your DC wiring, so your AC wiring generally will have a white and a black wire. Now, so of course the AC stands for alternating current. And this is super essential for you to understand when you have a home that you want to do electrical wiring in. But the way this works is there's 3 wires inside of the wire, the main bundle of wires. There's a hot wire, a neutral wire, and a ground wire. So they are color coded for safety. The colors indicate the function of each wire, and the black is always going to be your hot wire. So when you're doing AC current, that is the wire that goes up to, that is going through your switch and goes up to your light. The white wire is known as the neutral wire. And so the electricity is always going to flow through the hot wire into the device you want to power or to a receptacle. And then the electricity flows back through the neutral wire, and that completes the circuit. Now the ground wire is there to remove extra power in case you have any, and it sends the signal back to the breaker, and that can actually throw the breaker and stop the actual power from going. So the bare wire, it's either green or it has just bare wire. They always connect to other green ground wires, so remember that when you're actually doing your wiring. You don't want to bypass the ground if you can help it at all.
All right, guys, so now that you know about AC current, you realize that there are 2 wires that we're dealing with, and 3 if you include the ground for 110 volt AC. Now this is MulWark. This wire is approved National Electrical Code for inside the walls. It gets stapled to your studs there inside the wall. And this is what electricians use, and there's different gauges of wire depending on how much amperage that these guys are going to hold. This guy doesn't have it marked clear enough so that I can read it, but this is a lower gauge wire. Now the higher the number in gauge, the smaller the wire is. This is probably 16, so it's not going to be running some high amperage level. It's probably just designed for a low amperage circuit, which is fine. You just need to know how many devices you're going to be, or how many receptacles you're going to be having, and how much your actual circuit breaker is designed to handle. And this comes in big rolls, so you can buy this stuff off of Amazon, and I'll have a link in the description. So this is called Romex, R-O-M-E-X wire. It's been around for a really long time, and it's got that, shielding on here, and inside of there is a paper around the wire, and there is a white, a black, and a ground inside there. So that's your Romex wire. That's the first thing you need to wire up a receptacle, and hopefully your electrician left this stubbed out of a wall box for you long enough where you can install this guy. Some of the other tools you might need. This is an electrical tester here. So this is designed to test whether there's electricity. You see that it responded with a beep. It also has a nice little light on the end. But oh, the lights went out here. Let me go and grab that light so we have a little bit of extra. All right, now we got good lighting again. So here is the electrical tester. I will put a link in the description to this guy. Super helpful. And then I also have this electrical tester, which you can tell if you wired up a receptacle wrong. So if you put it in the receptacle, it shows you lights, and this one just lit 2 orange lights, and there's a code right here. saying that that is correctly wired on that one. You probably couldn't see it because the camera's a little bit out of the way. Electrical testers right here. Receptacle from any hardware store or Walmart. Romex wire. These are workman pliers. These guys are designed to deal with cutting Romex. So they're thick, they can cut through this no problem. Workman's pliers, you gotta have those, link in the description. Standard Phillips screwdriver, gotta have that, or a flathead for these. Don't rely on a power tool. That last little crank is what gets you your accurate and your reliable connections here. Wire strippers. Now these are hit and miss with solid copper wire. These things work great with braided wire. I don't think I have any around here. But with copper wire, they tend to fail. I don't know if it's just this exact brand or this one, but it tends to pull. It doesn't actually grab the insulation well enough, and so it tends to strip those insulations off wrong. It works awesome with speaker wires though. So that's a automated stripper, one of the audio installers' favorite friends of all time. Electrical tape. I buy in bulk. This is commercial vinyl electrical tape. I always have a ton of that around, and I'll show you why once we get into the nuts and bolts of doing the actual wiring. Now, the way this receptacle is designed, there are two ways that you can hook this receptacle up. Well, there's probably more than two ways, but the two basic ways that you can make this whole circuit one is either with the screw terminals on the sides or with the push-in terminals on the back. So, what are the differences? Well, a lot of electricians refuse to use these push-in terminals, but yet when I go into a lot of wall receptacles, I see these guys occupied. So somebody's using them. Now, the only drawback to these guys are, depending on the receptacle, this hole might not be big enough to accommodate the wire that you have. Now, this is smaller wire. I feel confident that I can get it in there. Now, the way this works in the back is you push the wire in and it stays. It's going to lock on. To get it out, you need a small screwdriver. So I have one here. So it has a flathead blade. And so you take one of your really small, they make little electrician screwdrivers. You take this little screwdriver, you push it in this notch here to release the wire out of these small holes if you ever need to replace these guys. So let's add that to the list of things you need. You need a small flat blade screwdriver if you're going to use the quick release and quick connect on the back. And if you look closely on this receptacle, when you're facing this receptacle, the white wire always goes to your left. The black wire always goes to your right. If you don't remember, it's written on the back of the receptacle right here. It says white right there. Flip that around and this is white. Now notice also that this receptacle comes with these terminals out. So if you're using these quick connects, you can go ahead and run these terminals in. And if you have a power screwdriver, you can do that quickly. And I will put a link in the description. But here is my handy little Black & Decker quick screwdriver, which has a little blue LED on the front. Put that here with the tools. So first I'm going to show you guys how to strip back the wire. So you want to strip back about 3 or 4 inches if you're doing new Romex. If you're replacing a receptacle inside of a wall, you're already going to have this already stripped back, but this is the installation. So let's add to our tools we need now. You definitely need a razor knife. And this is a cobalt razor knife. Link in the description. Here's what you do. So you lay that Romex flat, take your razor knife out, and you pull off. You go about 4 inches back, you push that razor knife through, Now I've got that slice nice there. Okay, now notice it just pulls right off. And when we pull it off, you see that there is a paper around the ground. Pull all that back to here. Take your razor knife here and go ahead and cut that off. You don't need that anymore. Throw that in the trash, and here's what you have left. You've got your white, your black, and your ground, all three of those going to the receptacle. Now, if you have an older home, you might not have this ground. Hook it up anyway, if you can, to the receptacle, and then inside the box, you're not going to be able to terminate that anywhere, but go ahead and hook it up here. Now, what you want to do for stripping the wire back is take off about 1/4 of an inch of wire. These handy auto strippers don't work well with this solid copper. So a real electrician will use this. They will just run it around squeeze it around the edge. Now this is really thin wire. You can cut through it really easy. So if you do a little turn like this and then pull out, you notice that might not be enough for the push in on the back. You might need a little bit more than that. So let's do the other one just a little bit deeper, maybe like 3/4 of an inch to see what happens. So just a little bit of pressure on this guy and turn your workman pliers, and then take your workman pliers and squeeze. Not too hard, you'll take off the whole thing, but there we have a stripped back set of Romex wires. Now let's take a good look at our receptacle back. Like I said before, we've got white for this side, black for this side. Why are there 4? So let's take a minute to look at why there are 4 screws right here. So directly out of the package for this duplex receptacle, this one from Eaton, this is made by Eaton, you'll notice that there are 4 screws here. The reason being is that from the factory, these guys are always joined together with a copper plate that is right here. Right in the center there's a little copper plate. Now what that plate does is it makes basically this connection one. Doesn't matter if you put the wire on the bottom or the top, as long as this copper plate is still attached. It goes for both sides. Facing this receptacle, left always goes to your white, black always goes to your right. Sorry, white left, black right, if I said that incorrectly. Now, let's say that you want this bottom receptacle to actually control a lamp. Well, in that case, your black wire would be switched from your switch in the wall, and your white wire would be still connected to all the other whites. So how do you do that? Well, it's pretty simple. There's a little tab right here. It's a little copper tab, and if you have a set of needle nose, which I will get out now. You know I have some needle nose in here somewhere. Any pliers will work. You take this tab, you squeeze it with your pliers here, you turn it and turn it and turn it, and this will break off on both sides. You got to do it both times. What does that do? So that separates the circuits here. That makes the top 2 screws independent from these bottom 2 screws. That way you can have your bottom part of your receptacle switched from a switch and your top part constant, or vice versa. So in that case, if you're not familiar with electrical wiring, you would need assistance from an electrician, but basically the output of your black wire from your switch would go to here, and your white wires would all combine together inside the box, and that would go to here, and then this bottom would be switched, or the top if you do these top 2 screws. Doesn't matter if you do top or bottom. But if you separate this little tab here, this becomes a separate circuit. But let's concentrate now on how you do the wiring. And I can tell already this is a little bit too short, so I'm going to take off some more of this guy. So you just squeeze and turn, not too hard, you'll clip right through the Romex sheath, but okay, that didn't do it all the way. So if it doesn't, just try again, and that time I got it. Notice I made a little notch by pressing too hard. And now that we have our bare wires, let's look at the back of the quick connects. There's 2 holes right here where you push in. All you do is push. Clearly labeled white right here. So take your white Romex wire, push that in. Now look at this. It went in. Look at that. I want to show you guys up close, but it went in and that guy is not going anywhere. See how I can't take it out now? All right, so that's what you want on that. Take your black wire, and once again, it's clearly marked. Hot wire here is your black. The other one's neutral. Take your black wire. Get a little bit closer here to the camera. Take your black wire, push it right inside that hole. And notice how it went all the way in with no bare wire. It went all the way. So about 1/2 inch was good. A little bit less than 1/2 inch maybe. Went all the way in to the back. Now this is good. It's wired. Now, if you are just using quick connect, now you can take your nice electric drill and run these in. Run the other side in like this. Now, more than likely inside your electrical box, you're going to have more peeled back than this from the Romex insulation, because you need to be able to bend this about like this, like that, to push it inside the box. And notice I made a U shape. That's how you push it inside your electrical box, to then use these 2 screws to screw it into the box, okay? And then your wall plate goes over the top of that. Now, don't forget your ground. Now let's talk about the way you bend the wires for screws, because we got to do that for this ground right here. So you always want to bend your wire the direction that your screw is turning. So in this case, it's clockwise. So we take our workman pliers, we go to the end of the ground. Ground doesn't have a quick connect. All we do is turn like that. Notice I made a nice hook right there, okay? All right, now we take our ground. You'll see the green screw at the bottom. You always want to go the direction your screwdriver is turning. It's got some safety catches right here, and we just wrap it around the safety catch so that the wire touches these 2 little metal tabs that are there. That keeps the wire from backing out. I don't know if you can see it there. There's a little tab right there, and there's one on the other side. Now, we take our manual screwdriver, since we're using screws, and it wants to pop out, of course, and we tighten. And a lot of times it's going to come out, so you got to keep pressure on it. Like that didn't stay in all the way. It's not properly in there. It's got to be in all the way. And if it gives you problems, take out the hook and make it a little bit more pronounced. Put that bad boy back in. Hold pressure on it like this while you're screwing it in. So I'm pushing on the wire with my thumb to keep that pressure on so it doesn't back out. Give it a good, nice twist there. Really tight, all right? So check it out. So that's how you properly put in the ground. And then you take these back wires, you make that U shape, and you push it right into that electrical box. And then you screw that in, okay? This receptacle is ready to go. Let's pretend this other end is connected somewhere up in the wall, okay? So we're good to go on that one. Now, let's say you don't want to use the quick connects. Well, there's another way to hook this up. So let's talk about disconnecting this. The ground's always going to be there. But let's take our little flathead screwdriver and try to get out what we already connected. So look in the back here, and there's a notch below where the wires go right here. You see that right there? That is the quick disconnect. Put our screwdriver in there, push, and at the same time we try to pull out our wire. And if it's difficult, your screwdriver might be too big, so that one's not working. So let's get a smaller screwdriver. Here's a very small one. You can almost feel, okay, see that? It popped right out. you can feel when the notch goes inside and it releases the wire. So let's try that again here with the black wire. Came right out. See that? So that is how you remove a receptacle that has used quick disconnects. There's a little notch right there below. You see the screwdrivers in the notch? That's it. That is what you do. Now, let's talk about how you wire this up the other way, and that is to the screws, which a lot of electricians are diehard about. So the way you do that is open up your screws all the way. Now don't go too far, they'll come out. You'll feel the stopper right there. Notice I've got these screws out as far as they can go out here. See them on the side there? Okay. So this guy's ready to accept these wires. Now remember what I said, guys. Always bend your wire the direction of the screw turning. So the white wire goes forward, the screw goes clockwise. Let's bend it that way. Take your workman's pliers. Now it's got to bend towards the front of the receptacle because the screw turns that way. So I'm going to take this guy here and bend it this way. And now we've got a nice, and use your workman pliers to close that up a little bit if you have to, and also manipulate it. That's what they're for. Makes working with wiring easy. Now we've got a nice U right there. See that, guys? All right. Take that and put it around the screw now. And now what you do is you pull pressure towards, you put pressure on that screw. Go ahead and tighten that up while you have pressure on it. And once it gets tight, go ahead and bear down on it. That guy's in there all the way. See that? And it's always white on the left, remember that. Now this other guy, your black wire, actually turns backwards away from the front of this. So we're gonna bend that backwards. Take your workman's pliers, bend a nice hook. Squeeze it if you have to make the hook more pronounced. Take that, put it around your screw. Hold pressure with your thumb. Take that and tighten it down. If it pops out, try it again. Redo your bend if you have to. One good turn, that's not going anywhere. All right, now, both of these guys are hooked up now because of that tab is still in place here. That metal tab right there is still there, so the bottom screws are powered too. Take your wiring and make your little U shape like that. Push it in the box, and then take your screwdriver and screw it into the box with these two screws. Then your roll plate goes into these two holes right there. So this receptacle is properly wired now. Now, can you run another receptacle off of this? Absolutely you can. That's what these bottom screws are for. Generally, they will take another piece of Romex, come off these bottom screws, and they'll feed the next receptacle down the wall. Now, one of them obviously is the start point. So if this is the last receptacle, this is where you stop. If it's the first or the middle ones, you're going to have wires coming out of here and going to your next set of receptacles. But if this is a switched bottom part of a receptacle, it'll be a totally separate wire. So that is how you wire up a receptacle in your wall. Now, if you're just replacing the existing receptacles, always remember, try not to cut too much wiring off, because if you do, you won't have enough reach to get the new wire onto the screws or into the quick connects. Now, one last thing that I like to do, and this is all just literally up to whether you feel like doing it or not. Take your electrical tape here. Got a set of regular electrical tape, a roll here. Of course, it's annoying, you can't find the end, but take that electrical tape here and take that out like this. And the screws are kind of in the way here, but put it under the screw and wrap that guy like this. Again, you got to get it under the screw here, so when you go to the bottom, kind of go underneath the screws that hold in the receptacle to the wall, and wrap that guy like this, and Bingo. Pull that tape off. All right, now, so what does that do? So basically that prevents any kind of short when you are working on these receptacles, and it just really is just an added measure of insulation and protection for these guys. So see how I wrapped and you have to go underneath the screw there. And that is how you wire up a receptacle, guys. Now, of course, the opposite, once you're on the screw, is self-explanatory. Let's pull off our tape here. Got our tape off. Opposite, self-explanatory. However, the one tricky thing is sometimes it's hard to get off this hook. Just, you gotta kind of manhandle the wire to get it off. And then same with this guy, if it's kind of stuck in there, turn the screw all the way till it won't turn anymore. And then you just kind of bend the wire around it. Same with the ground. And then take that wire and bend it around it, and then you have uninstalled your receptacle. Once you are done, take your tester, if you feel like it, test that wire. So here's how a good example of, turn the power back on first, obviously. And oops, wrong one. Power will show on this. Take your tester. This shows you if you wired it right. We got 2 orange lights. 2 orange lights on the bottom of this means it is properly wired. And you have put a receptacle in, guys. Can you believe it? You did it. I got faith in you guys. If you need any help, hit me up. Feel free, leave me a message. We can email back and forth. First things first, go out and get all these tools you need. Be prepared. It's nice to have all the tools you need and not have to do anything, you know, halfway. These are tools that are a necessity if you're doing electrical work. I do a lot of my own electrical work here, so I keep my tools. If you take a few minutes every time you're done to put your tools back, you will always have them the next time. And the Romex and everything that you need, all the electrical tape, I'll have links to that in the description. And I hope you guys enjoyed this video, and I hope to see you next time. Peace.